All right, so welcome to Cryptocurrency and Blockchain. My name's Zachary Munier. I'm the lead library specialist for the Martin County Library System. I'm joined by my co-host, Casey Hudson, digital literacy librarian. She'll be my co-host for today. Like I said, she'll be monitoring the chat, asking any questions that you guys have. Like I said, your microphones will be muted when you come in. If you have any questions, just type them in the chat, and we'll every few slides we'll pause throughout the presentation to address you guys. And in a few days next week, the presentation will be emailed, a follow-up email to all the registrants. Any questions that we don't get through today, we'll try to find an answer for you by then and include it in the email, and then some extra resources like some LinkedIn learning classes that you guys can explore once you're done with this presentation. Sound good? All right. All right, so objectives for today. First, we're going to define what blockchain is and how it works. We're going to compare blockchain to traditional methods of storing and sharing data, compare types of blockchain networks, explain how cryptocurrency uses blockchain, which is the hot topic right now, discuss potential problems with blockchain, and explore potential uses of blockchain. And here's a slide, just says, don't be intimidated. This class will be more of a bird's eye view of the large topic. I mean, this is a big topic. We could be here for a while. That is cryptocurrency and blockchain. I'll be leaning more on blockchain in this class because that's the technology that is behind all these currencies. That's what it's built upon, and has many more uses outside of crypto that I think are pretty interesting. I'm certainly not an expert. I don't expect you to be. This technology is very early still. People are still figuring things out. So, and like I said, I'll be sending a follow-up email for all your questions and some extra really good resources and courses through LinkedIn Learning that you can get free with the library. All right. So what is blockchain? A blockchain is a type of computer network that stores data in blocks linked together to form one another, form a chain of information. So a network definition basically is a collection of computers that share information between them. It can be described as a digital ledger, like a ledger in which you write down like transactions, the dates, the amount of each transaction, like a book, like I pictured here. In which each person on the network has their own copy of the ledger, and each block of data can be thought of as a page in the ledger, like a new page added to the book. New data, a page, can only be added if all the computers on this network agree that the information on the ledger is correct and valid and matches each other. And ledger is kind of the vocabulary when talking about blockchain and Bitcoin and stuff like that. It's kind of how the data is presented to you. And here's a short little video kind of doing a good introduction to some of the uses and stuff about crypto and blockchain.
Modern technology allows people to communicate directly. Voice and video calls, emails, pictures, and instant messages travel directly from A to B, maintaining trust between individuals no matter how far apart they are. When it comes to money, people have to trust a third party to be able to complete a transaction. Blockchain technology is challenging the status quo in a radical way. By using math and cryptography, blockchain provides an open, decentralized database of any transaction involving value, money, goods, property, work, or even votes, creating a record whose authenticity can be verified by the entire community. The future global economy will move towards one of distributed property and trust, where anyone with access to the internet can get involved in blockchain-based transactions, and third-party trust organizations may no longer be necessary. The uses of blockchain technology are endless. Some expect that in less than 10 years, it will be used to collect taxes. It will make it easier for immigrants to send money back to countries where access to financial institutions is limited. Financial fraud will be significantly reduced, as every transaction will be recorded on a public and distributed ledger, which will be accessible by anyone who has an internet connection. Think of it as wills and contracts that execute themselves, or dated proof of existence for ideas, much like a patent. Blockchain will become a global, decentralized source of trust, but not everyone is ready to embrace it. A huge proportion of trust services, from banking to notaries, will face challenges on price, volume, and in some cases, their very survival. Public authorities could find it more and more difficult to enforce traditional financial regulations due to the new possibilities offered by the Bitcoin network to bypass traditional financial intermediaries. Unimagined new networks will evolve to meet society's needs more cheaply and potentially more securely. Will governments, financial and legal institutions embrace blockchain? What will happen to the ones who don't?
All right, so yeah, that was a video by the World Economic Forum talking about some of the future impacts of blockchain from, again, a bird's eye view. And one of the big points of this video that I want to stress is that when people talk about like transactions in blockchain, or they're not always talking about Bitcoin or something to do with money. I mean, Bitcoin has uses far outside of just monetary uses. It can be used, like they said, for taxes, like to notarize information, databases of like records of personal information and stuff like that. I mean, it can be used for a lot of different things. So when you hear transaction, it's not always just a transaction with money. It can be also just a transaction of data itself, and that data can represent anything. And we'll dive more into these concepts as the class goes on. But you did notice they use the word ledger there. Like I said, that is a pretty common term. All right, so blockchain versus traditional data storage. Traditional data storage relies on centralized servers that all users request access from. A server is a computer that provides information or data to other computers. So think of a server like a server in a restaurant. They bring food to you that you want to eat. The food in this case would be information or data. So the server serves you the data. But unfortunately, this creates a point of failure. So if one of the servers goes down, data is lost, and it's not accessible until that server is brought back online. So I'm sure you've experienced not being able to connect to something because servers are down. Creates a big problem, like a kind of a big traffic jam, if you will. Blockchain storage stores data across all users on the chain. So all users on the network that are involved in the chain. So that creates a lot of less points of failure because it's between computer and computer, not between computer and server. Unfortunately, those data can be slower to access because it has to ping pong between a lot more places and try to seek the information that it needs, but it can be a little more reliable than traditional centralized servers. Okay. And then we'll get to just 2 more slides here, and then we'll pause for some questions. So cryptocurrency and blockchain. So Bitcoin is the most popular cryptocurrency that uses a public blockchain network, and we'll get to what that means in just a few slides. And keep in mind, a lot of this stuff can be applied to other cryptocurrencies. You might have heard of Ethereum. That's kind of a big crypto right now, and there's a bunch more, but for these purposes, I'll just use the name Bitcoin to refer to a cryptocurrency. So transactions happen on a person-to-person basis. No central bank is involved, or no third party for transactions, I should say. A complete transaction history is visible and transparent to ensure validity, to ensure that the information is correct. And as a result, transactions can be completed much faster when you don't have a bank that has to sign off in each transaction or take a look at things. Since things happen from person to person, you can have transactions happen within, hours or maybe sometimes even a few minutes. So this is kind of like a flow chart here on the right, kind of showing the process of a Bitcoin transaction. So you want to buy something or receive Bitcoin so that it's entered into the chain. The transactions then transmitted to the network of peer-to-peer computers, the blockchain. This network of computers then solves equations, hence the word crypto, equations to solve the cryptography to confirm the validity of the transaction. We'll go into that, like I said, in a few more slides. So once they confirm it's valid and confirm to be legitimate, they are clustered together into blocks, so blocks of data. These blocks are then chained together, creating a long history of all transactions that are permanent, hence the ledger. So this will be like a complete history of everything that's happened on the chain. And then once that's done, once it's entered into the chain, the transaction's complete. And we'll get into like Bitcoin mining that factors into it. And like I said, Ethereum, that's another popular currency. And yeah. So a pretty common question you might ask is, well, how do you buy Bitcoin? How do you get your hands on it? And I have a few examples here. So there's, you can go through an exchange like Coinbase. There's Webull, like trading apps, Robinhood, Webull, PayPal. You can get Bitcoin on there, or you can use a Bitcoin ATM, which is on the right picture here. So you can kind of think of it as like a security, but not really the same. It's just usually found on the same kind of apps and exchanges that those kind of things are found on. So how do you access your Bitcoin once you have it? All right, so you have something called a digital wallet that can be accessed online through these previously mentioned exchanges. So a lot of these apps will have like a place where you can view your transactions and how much Bitcoin you have. And another secure option instead of a digital wallet would be a hardware wallet. So this is on the left, this kind of USB stick looking thing. This is where your keys and Bitcoins are stored offline on a physical device. So they're not connected to the internet. They're like actually stored on there physically. So they can be connected to a computer or phone when you need to access the currency. So this is much more secure because it can't be hacked unless someone steals it. You can think of it kind of like cash. If someone stole your wallet, then you don't have the cash anymore. But no one can like steal your wallet without getting their hands on it, basically. It's not like a debit card or anything like that. All right. Okay, so any questions in the chat?
Yeah, we have a couple questions, Zach. Can you hear me okay?
Yeah, I can hear you.
All right. So one question, how does one know that all the information in the ledger is correct?
Okay, I mean, that's something that will be answered in a few slides later in the presentation. But it's usually like it's a consensus between all the computers on the chain. So each of them, they work together. All the computers work together kind of as like a farm of animals to make sure that like a farm of computers, a farm of power, they kind of pool their power together to just to make sure and make sure that the information there is valid. So it kind of like presents a cryptographic code, like a scrambled code that all the computers have to decrypt together. And then once that's decrypted, then that's considered valid.
Great. Yeah, and I think we're getting a couple more questions that you're going to get to too, but this is good because
yeah,
that means we're covering the right stuff. Okay, so another question. The audio implied contracts and their execution. Does that mean a future defined activity will be initiated and then executed in future state?
Yes. So once the transaction is verified, then then the contract will be executed, and then there's a record of that contract on the chain that's accessible. That's the big thing, is that everything is transparent and accessible on the chain.
Great. Yeah. Okay. Next question. If a worldwide power failure happens, what happens to the blocks?
That's a good question. It's like some kind of doomsday scenario, like a EMP or a solar flare goes off. Yeah, that's a good question. I mean, I'd say similar to servers that we have now. I mean, they're susceptible to any of the same things, since they're electronic and they're computer. I mean, they're just computers. When I say computers, they're computers like you and I have. So when you're interfacing with a blockchain, it's happening on your computer. It's not happening on some specialized server in some remote place that you connect to. So yeah, I would say if your computer is susceptible to a worldwide power outage, then maybe if one computer was left, then if one computer was left unscathed, then I guess the record would still exist, but it would be hard to make transactions because there'd only be one computer's worth of power to validate new transactions. So that would be the problem.
Okay, a couple other questions. I might wait on asking some of them because I think we're going to get there.
Okay.
But just something we've already covered. If you lose your hardware wallet, have you lost any way to access your Bitcoins? I asked the same question as Zach.
That's a good question. I'll have to look into that. That might have to depend on the manufacturer of the hardware wallet. I'm not sure if there's like an account that it's connected to or anything like that, but I'll have to look into that and get you an answer on that in an email.
And you told me that if you lose that, if you lose the USB, it's gone, right?
Yeah, my gut says it's gone, just like cash would be, but I'll double check with the manufacturer to see if there's like some kind of account backup or anything like that. But I think the purpose of the hardware wallet is that you don't have that. You don't have to sign into anything. It's accessible physically on the device. So yeah, if that gets stolen, then that Bitcoin is gone. Just like cash. Just like you don't have to sign into an account to access your dollar bills in your wallet. It kind of brings the digital into the real world in a way.
Okay, couple other questions if we've got time, or I can
Sure.
hold off. All right, so someone asked, what would be an example of third party?
Okay, so let me go back a few slides here actually. Oh,
Great.
Just one slide. So third party, so it would be an exchange like Coinbase or Robinhood or Webull. So it's a third party that you access to buy the Bitcoin or to sell it, or to do transactions between people. So that's the third party that facilitates that. Not to do transactions, just to buy and sell Bitcoin, but to do transactions, it goes from person to person. That's the main difference, is that there's no third party checking, like no bank signing off on it or anything like that. So the process takes quicker. The only like third party you could say is like the network of computers, but it's not like another entity, taking a look at what transactions you're making and stuff like that.
Okay, and then I think a follow-up question to that, which I don't know if it's just me, but your slide is not quite showing. Can you just go forward or backwards one slide?
Sure.
Yeah, there we go. Now it's showing.
Okay.
Okay, so follow up on that. Please discuss how a contract works real time. For instance, I want to buy a widget from company X. What takes place?
So like you want to buy like something online with Bitcoin, it pretty much happens the same way as any other kind of transaction, like Apple Pay or just paying with your debit card. I mean, what you see is pretty much the same thing as far as like buying Bitcoin. It's made not to be too much different than any other currency.
Okay, and there's a couple questions on privacy and fraud, but I'm just going to wait on those because I think you're going to talk about some of that.
Yeah, we'll get to some of those things later on. But as far as like the real-time thing, I can try to find some articles or videos to explain that a little further, because it's kind of hard to know what I'm saying until you visualize it. So that question I'll keep in mind for after in an email.
Great questions, everyone. Thank you.
Yeah, these are really good questions. Thank you. All right, so I know we mentioned a public network before. That's Bitcoin's an example of a public network. So these are different types of blockchain networks. So public networks, any user can join and be a part of the network. In order to add new data, more and more power will be required as the network gets bigger. It's the most popular type of network for cryptocurrencies since, since they're monetary, you want as many people on the chain as possible. You want as much less barrier of entry, the better for currencies, basically. And so it can be used more widely. It can be higher adoption with different vendors and stuff like that to buy things. That's why it's public. Private networks are similar to a public blockchain where the power is decentralized. However, the network is managed by a single entity, typically a private business. So this entity reaches consensus for proof of work. We'll get to that definition later. And maintain. So basically, like they validate transactions and maintains information contained in the ledger themselves. And the power required can be controlled by limiting how many people can join. And there's kind of two subtypes in the private networks. There's permission and consortium. So in permission networks, users can have restrictions placed on them about which kind of transactions they can take part in. It's meant as an additional layer of security as only certain users on the network can perform certain actions. And a consortium network is a type of private network where instead of a single entity, it's actually a group of entities that come to an agreement to control and govern the ledger. So like when I say that in order to add new data, more and more power will be required as it gets bigger. To validate, as more transactions happen, it's purposely made more hard to decrypt and validate each transaction because there's more data to process because they're processing the whole ledger. So as the network gets bigger, more transactions, more people, more computer power is needed. All right, so security. This might answer some of the questions that we had before. Blockchain makes use of sophisticated cryptography to encrypt, in other words, secure data, hence the name cryptocurrency. Concept of proof of work. This is important. So when someone wants to add new data to the chain, all computers on the network will have to decrypt the previous transaction made and check to make sure all previous data matches. So it's kind of a check to make sure that what they're adding to the ledger is valid. In order to manipulate the data on the blockchain, a group or individual would need to have more than 50% of the total computing power on the network. And that means that, for blockchains like Bitcoin, I mean, so many people are using Bitcoin now that it would be 50% of the total computing power on that network would be inconceivable or infeasible if someone wanted to try to, it couldn't just be one person that had that access to that much computing power. So it's pretty much impossible for that to happen. And that's kind of proof of work is another way of saying Bitcoin mining. That's probably a concept you've heard on the news here and there. It relates to what proof of work is. It's kind of the computers that are decrypting the last block's quote unquote puzzle. Those computers decrypting and are referred to the miners. They're trying to find like a key by working backwards from the solution. So in cryptography, you're trying to find like a key that fits into a lock that decrypts the scrambled data. So when the puzzle is solved and it's successfully mined, that's when the new block is added to the chain. That's when it's validated and it confirms the previous transaction. All right. So a little bit more on security and actually some potential issues with this blockchain concept. So while blockchain is much more secure than typical data storage, it is still prone to hacking with the use of phishing scams and something called Sybil attacks. I'm sure a lot of you have heard of phishing scams. I mean, phishing scams really don't have anything to do with technology, because it's more of a human problem. It's manipulating people into giving information, not so much the technology. So some platforms, like I mentioned before, offer users virtual wallets to store the cryptocurrency. And those platforms are vulnerable to many of the same scams and attacks as other online services. So at the end of the day, there's just another online entity that can be prone to hacking, just like anyone else. And here's the definitions for Sybil attacks and phishing scams. So Sybil attack, it's when a user creates a large number of fake identities to overwhelm and take control of a blockchain network. So this doesn't happen. So this happens not on the blockchain side, but on the platform side. So they create a lot of identities or accounts and try to overwhelm the network or the exchange that is handing out the cryptocurrency. And there have been some steps to mitigate that. I mean, that's something that is being, it's not happening as often anymore. And phishing scams, a fraudulent message that's sent out and designed to trick the user into giving up personal information. So it's not something that really has to do with blockchain specifically. It's something that happens. It can happen with any kind of data, right? Any kind of information. And then something that's kind of exclusive to cryptocurrency is something called a pump and dump scheme. So it's when someone convinces a large group of people to buy into a cryptocurrency to drive up the price of that currency, at which point they sell their coin and they make a profit and once they sell it, the price goes down and everyone else loses money. And this is something that happens only in private networks. It couldn't happen on something like Bitcoin because no single entity controls the flow of the currency. It only happens on private or consortium or consortium networks and stuff like that. So that's something that, if you use Bitcoin or Ethereum, like I mentioned, that's not something that will happen. All right. Any questions about that?
Yeah, I'm going to revisit some of the questions from earlier.
Okay.
So one question that I got through direct message: how do users lose money through fraud? We've seen some news coverage recently.
Yeah, so like I said, fraud is a lot of times it has to do with the person giving the information due to like phishing scams or just, they call it social engineering. That's what a lot of hacking is. It's just manipulating people into giving up information. Or like you see a coin that seems legit, and someone says like, oh, the price is going to skyrocket if everyone buys in. It's kind of like it's in some ways similar to a pyramid scheme. Where people are like, someone's convincing you the more people that sign up or not sign up but buy this coin, the higher the price will be, and it's just like the snowballing effect. But at the end of the day, only a few people can realistically make money. A few people that hold the most coins, and then a lot of people at the bottom lose money because the price goes down and they're holding currency that's basically worth nothing. So yeah, a lot of fraud is basically just typical classic schemes and stuff like that.
Another question from before that I waited to ask, a couple questions actually. What about privacy between buyer and seller? Does everyone have access to information in order to verify a transaction? And I don't know if you want to talk about that. I can't remember if that was in terms of like blockchain technology or Bitcoin or cryptocurrency specifically.
No, there's not information on like names or anything like that. It's the information stored is like what transaction was made at what date. That's usually the information that's stored on a blockchain. It's not anything to do, nothing in blockchain asks who you are, as far as like, it doesn't want any of your data. But when you buy Bitcoin or when you make transactions, you have a personal key, like a personal password kind of, that you don't even know what the password is, but it's basically a way of validating that it's you. It's kind of like a digital fingerprint, if you will. Like only you have this fingerprint, but like no one else can have the same string of numbers and letters and stuff like that. So that's the only way you're identified, is through that key, but no one else can see it. It's only used to verify the transaction, that it's you making the transaction, I should say. But no, the only information stored is the date and the amount that is moving around.
Okay. I'm skipping around a little bit with these questions, so forgive me, those of you that have asked them. One question I think was a follow-up to the first segment too, is I read somewhere that someone lost or couldn't remember their password and couldn't access their account. They lost millions of dollars worth of Bitcoin. I thought you said that a person doesn't have a password. What am I missing here?
Well, they might have been using an exchange to access their Bitcoin. Like I said, these companies like Coinbase and Webull and Robinhood, you're still accessing it from an account to get Bitcoin, but it's just one way of getting Bitcoin or storing Bitcoin. Like I said, another solution is the hardware wallet, where the Bitcoin's stored physically. There's no account attached to it. But if you buy it through an exchange, you still have an account with that exchange. And if you lose your password, that's just like any other account. You'll have to try to recover it or remember it. And if you can't, then it's lost. So for certain ways of acquiring Bitcoin, depending on how convenient you want it to be, you'll still need an account, but that's not always the case. And I can try to find some resources to go a little more in depth of what those options are.
Just a comment, I think that it was in the context of the 50% of the network but just a comment that Bitcoins lost 25% last month, gained 40% this month. That kind of volatility does not create trust or confidence. So just a comment.
I mean, there's all sorts of things can drive up the price or bring it down. I mean, you saw in the news that China banned all cryptocurrency, and that caused the price to dip. So like I said, this technology is pretty new. I mean, it's only about 10 years old, and it hasn't really reached like public awareness until fairly recently. I mean, Bitcoin's been around for 10 years, but it was only kind of kept to a niche group of people. But I mean, right now, since it's like everyone's trying to figure out what this is, and then like governments are trying to figure out how they can use it. It's very volatile right now. But we'll get into some examples of like future uses for Bitcoin, or not for Bitcoin, I should say, blockchain technology. Maybe in the future, cryptocurrency isn't a thing. I mean, maybe that's not what blockchain ends up being used for in the long run, even though it's the most popular right now. Maybe blockchain can find its way into other areas of industry.
And there is a question in the chat about governments regulating crypto, but I'm going to wait for the next question because I have one more question I'm going to ask you right now.
Okay.
And that is the owner of the computer aware that the computer is validating or proof of work in real time?
Yeah, you should be aware. I mean, it doesn't, you can allow it to use as much of your computer as you want it to. It doesn't really use up that much computing power. It's mainly more dependent on the, like typical computers aren't actually very good at validating transactions. There's like specific processors built to validate transactions. And we'll get into why that's a problem. Actually, did I mention that? I actually didn't mention that. That's good thing you asked that question, because that's another thing. So these computer chips that are specifically designed to mine crypto, they're basically single purpose. They're only designed to do that one thing. So when they become obsolete, when a new faster chip comes out, they're basically just thrown away, and that creates a lot of e-waste as a result of Bitcoin mining. It's kind of like a gold rush where everyone's trying to mine as much Bitcoin as possible. So yeah, the stuff is just thrown away, and that's has an impact on the environment. And there's a lot of data as well about the power requirement as like Bitcoin gets bigger and these cryptocurrencies get bigger, how much power is required to keep the network running and where that power is coming from. So that's another conversation to have surrounding cryptocurrencies.
Okay, and like I said, there's one more question. What government agencies are currently regulating crypto? Do you want to answer that now or do you want to wait?
We'll wait on that. Like I said, the only one I know of currently is China. I know, in fact, actually some governments are actually using blockchain. They're not regulating it, they're using it themselves because they see the advantages of it. I can send some links to some articles that I've found regarding that. All right.
We'll move along, and then more questions I'll ask you at the next break.
Okay. All right, so current and future uses for blockchain. So the main one, the biggest one that I found was digital identification. So it can best be compared to digital driver's license. So it's kind of like, you can think of it as like sign in with Google or sign in with Apple. So those things that everything you sign into is through Google or through Apple. So it kind of makes remembering things easier across all these different accounts that we have these days. So each user that stores information on the chain will be given a unique ID code or key, like I mentioned earlier, that would prove that their information stored on there is correct and belongs to them. So there's an example where this refugee camp located in Jordan runs on a blockchain network, actually. So using biometric authentication, it makes the keys match and they know it's you. The refugees can make transactions without having to carry a wallet or prove their identity with paperwork. This kind of shared database has a lot of advantages because it could reduce the amount of duplicate information between different entities and organizations. It can cut down on the times you have to enter in basic information. Like every time you go to the doctor's office, you have to put in all your basic information every time. And it also gives you more control over what information you present to these entities, and you can update it yourself and stuff like that. So like everything from credit cards, government IDs, complete transaction history can be stored in this database, making it much easier to get around. Like I said, no paperwork. It's all digital. And another one is EU Decode. European Union Decode is a project that invests in blockchain related projects and aims to give people more ownership of their personal data by being shared in a way that allows the user to have more privacy and transparency about what their data is being used for. And I have a link to that in my notes, and I'll send that link about the Decode project in the email. All right. And here's some more, something called smart contracts. So these are programs that are stored in the blockchain and when validated, execute based on the terms set in the contract. It can be used in real estate for things such as titles and other public information. And it's currently being used in the pharmaceutical and other industries to track products as they move through the supply chain. So like food supply, everyone along the supply chain can look at the blockchain and see where the food is and where, basically the trip it's taking to get to its destination. And that means a lot more efficient communication between different entities. And then there's also NFTs. Now this is probably a pretty hot topic. It's had a lot of coverage recently, even though it seems like it's died down. So NFTs stands for non-fungible token, meaning that it's not able to be exchanged for something identical. It's basically a one-of-a-kind digital token. kind of similar to, like I said, with the fingerprint analogy, it's like a unique ID code that validates that it's this digital item. So yeah, the tokens represent digital items that exist on the blockchain. And it's kind of like a seal of authenticity that this digital item is what it says it is. And so examples of NFTs have included famous images, GIFs, tweets, other pieces of digital art. I mean, this is something that people are willing to pay lots of money for. So it's definitely a new thing. And you know, some of the advantages is that it actually gives artists a better way to make an income or receive money. So a lot of artists are actually turning to NFTs to sell their music or their art and stuff like that. So it's kind of the equivalent of like having an original painting for bragging rights instead of having a recreation of a painting or copy. That's kind of the same way to look at it, except it's digital. So it's like, instead of having a screenshot of it, you can say, oh, I don't have a screenshot. I have the original thing. Here's the key to prove it, basically. All right. So conclusions, blockchain, like any other emergent technology, has the potential to transform countless industries. It creates the option for a universal digital identity. And like all other technologies, unforeseen privacy and security concerns are expected. And, you know, usually with technology, most of that stuff is ironed out in due time. And here's a quote by Roy Amara. He was a computer scientist and futurist that researched future effects of technology. And his quote from him, he says, "We tend to overestimate the effect of a technology in the short run and underestimate the effect in the long run." So like that video in the beginning said, 10 years, you know, things could look a lot different than they do now because of blockchain. You know, blockchain and Bitcoin is being touted as revolutionary right now, which may not be the case, or it may be, but years and decades from now, it might have changed things in ways no one could have even imagined. So that's why it's so exciting. All right. Any more questions?
Yeah, we have a question which is good to kind of dig in a little bit deeper. What is Bitcoin mining and how does it work?
Okay. So yeah, Bitcoin mining, let me go back to that. So it's basically validating that transactions, it's validating transactions within a network. And that's kind of like, you can think of it as like, it's work. You're basically maintaining and helping the network stay alive and validate things. Actually, the big incentive for Bitcoin mining is actually right now, when you mine Bitcoin, you get rewarded with Bitcoin back. Now, there's only a finite amount of Bitcoin in existence, so that actually will slow down eventually, but it's going to take a long time for that to happen. But it is an incentive that by maintaining the ledger and validating previous transactions, you get rewarded with a new block of information, which equals Bitcoin. So it's basically you're mining for Bitcoin, and simultaneously you're mining for Bitcoin by solving puzzles of previous transactions that have taken place. If that makes any sense. I don't know if there's a way I can explain that better.
Okay. I mean, that helps to know like what the incentive is too, for me at least.
Yeah. Yeah. So
and I'll
like
just make a comment. Oh, sorry.
Okay. I'll say it again, like as clear as I can. So by solving puzzles of like scrambled messages from previous transactions, that adds a new block to the chain, meaning that that's new Bitcoin that is now yours. And then the process repeats where someone else mines your transaction to validate it and they get rewarded. But eventually there is a finite amount available. But like I said, it's a large amount. So.
Cool. I don't see any more questions in the chat, but I am going to go back to what government agencies are currently regulating crypto, because
Okay.
I thought you were going to cover it, but you said China anyway. The China is the only one
Yeah.
you know about.
Right.
But did I see something in a previous iteration? Sorry to call you out on like
Okay.
Estonia, something, some country using blockchain
Um,
or
yeah, there was it's a South American country that's using Bitcoin. I know the article somewhere. I'll have to find it after the class, but yeah, it was for data storage using Bitcoin. I mean, it's kind of an experiment more than anything. But that's the thing about these cryptocurrencies, right? Is like no big government is regulating them right now because they're trying to still figure out what they are. The SEC hasn't really cracked down on it at all. So only time can tell. Time will tell what these governments and agencies think of or what they do about Bitcoin in the future. If these hacking things keep happening or scams and stuff like that. And if the price becomes less volatile over time.
cool. Well, yeah, I still don't see any more questions in the chat.
Okay.
I hope I got to everyone's, but I will just make a comment. Like, I don't know about anybody else, but blockchain technology is one of those topics where I've just come to terms with the fact that I might never have a light bulb moment in understanding it, but just the more I hear about it, I feel like it's like a crystal ball that just keeps getting a little clearer. I can see a little bit more every time.
Yeah.
So this really helped me gain more awareness, more
Yeah.
understanding.
Yeah, I agree with that. It's one of those things that like you just need to hear a bunch of different people explain the same concept in their own way. And then until you find one that works for you, to try to find an analogy or comparison that you can, because that's really the only way you can wrap your head around it is comparing it to something else. So that's why I'm going to include those LinkedIn learning courses. I'm going to link a few by different people. So you can hear from different people and how they interpret Bitcoin. And yeah, hopefully you can get a little closer to understanding it better. But I think, like I said, understanding blockchain and the technology behind Bitcoin, then that's kind of the foundation that everything's built on. So if you know the foundation, more things will make sense as a result. Okay. Well, all right. So yeah, that looks like it's it. Here's
Just
some
got one
upcoming
question in the chat, sorry.
Okay.
Can crypto or Bitcoin ever be a bank issuing credit?
That might be a thing in the future. Right now, like I said, it's not. No banks are involved when you're issuing a Bitcoin transaction. Like I said, it's from person to person. That's kind of the big appeal of Bitcoin is that there's no central bank involved. So it's entirely dependent on the people to assign the value to it. There's no treasury or anything like that. But maybe in the future that happens. Maybe the United States government creates its own currency, cryptocurrency, like on a private network and regulates it that way. Who knows what the future holds, but that is an interesting possibility. All right. So yeah, here's some upcoming classes that you might be interested in. So we have intro to cloud computing. And then we have a virtual tech talk on Wikipedia. So the cloud computing is on the 4th here at Moorgate Library. So we talk about cloud computing and ways to use it. There might be some little nuggets of similarities there with blockchain, learning about networks and how those work and stuff like that. And then the virtual tech talk, Wikipedia. That's a pretty big one there. So it's kind of like how to use it, pros and cons. It's going to cover like kind of how to seek information on it. And that's pretty good because when you look for information on Bitcoin, maybe you'll have some extra tools in your belt for finding information on the web. All right.
Yeah, and if I can just chime in about the cloud computing, that's actually a really good parallel. Like 10 years ago, talking about cloud computing to people was really difficult. And even though the technology might not have changed a ton, our ability to understand it has really come a long way. So interesting parallels there, just in terms
Yeah.
of like consumer adoption of these emerging technologies.
Right. Because, yeah, that's a good point, because, the concepts behind blockchain and stuff like that have been around for a long time. Like proof of work has been around since like the 70s, that kind of concept. But Bitcoin was the first cryptocurrency. It was the currency that kind of introduced this whole blockchain technology to the world. So, there might be a currency down the road that's like easier to understand and wrap your head around, just like cloud computing. I mean, cloud computing was kind of like, what does this mean? And then, now all these big companies have it, like Apple has it. They're good at marketing. Google's good at marketing and kind of explaining what that is to people. So that might happen, that something similar might happen to cryptocurrency and blockchain in the future. We'll just have to wait and see. All right. So if you want to learn more, we have more classes, of course. You can sign up on our calendar there. Let us know what you liked. You can submit a survey. Like I said, all these slides will be emailed as well, so you can use these links. And if you want to find out what an idea lab is, we have the link there too. Those are my sources, and that's it. All right.
We did get a question in the chat. Are we able to listen to the recording presentation again? We are
Yes.
recording it. Oh, go ahead.
Yeah, we are recording currently. So yeah, you'll be able to listen to the whole presentation and all the questions and the answers. So if you just want to review anything, any of the slides or anything like that, you'll be able to do that. I'll include that all in the email. All right. Well, if there's no more questions, I think I'll go ahead and call it there. All right, so thank you, everyone. Like I said, next week you'll get a pretty comprehensive email with some resources and stuff like that. But yeah, thank you for coming. If there's any feedback you want to have about this class, you can always submit a survey. Tell us what you liked and didn't like, and yeah, hope you all have a nice day. Thank you.
Thanks, Zach.
Bye-bye.
Bye, everyone.